Hey, you lovely lot. I'm Teacher Jess, and welcome back to Geo Cafe. How are you doing? I hope you've been keeping well. I hope you have your coffee, as always. Okay, what I want to take a look at today is a very important basic about the atmosphere, and that is the structure of the atmosphere. And because there isn't necessarily a lot of content on just this fundamental part. I thought we could also try a little quiz at the end of it, and I'll see how much of my own lesson I can apply to a quiz that has been set. Okay, shall we give it a shot? And let's get started. Okay, so the structure of the atmosphere. We're not just going to be looking at the different layers of the atmosphere, we're also going to look at what it's made up of. Okay, so just the basics of what is the atmosphere, what makes up the atmosphere, and how it is actually layered. Okay, so what is the atmosphere? That is the layer of gases that surround our Earth. It's what keeps our Earth habitable. It helps keep everything at a nice temperature. It keeps moisture circulated, oxygen circulated, everything that we need to survive. Okay, so the main composition of the atmosphere is gas, but it does contain some liquids and solids as well. So the main gases that we're familiar with is nitrogen, oxygen, and argon. Okay, that's probably not the ones that you're most familiar with. These are the biggest percentage of gases. Okay, so about 78% is nitrogen, about 20, either 20 or 21 20.9 or 21% is oxygen. Then you have about 1% that's argon and a little bit that's other gases. Okay, it does also consist of liquid. So that is when you have water vapor condensing and making clouds. That would be your liquid or any type of precipitation. And sometimes solids as well. That could be an example, ice. Okay, so gases, we can generally categorize the gases into two main groups. The one is a permanent gas and the other is a variable gas. What makes a permanent gas permanent is that the proportion of that gas doesn't really change very much. Not significantly, not notably. So that's why these percentages are ones that we can actually learn. So we can learn that nitrogen is 78% and oxygen 21%, but we can't exactly memorize the percentage of carbon dioxide or um, water vapor because those levels can change. So nitrogen, very important part of the atmosphere. All living things, all kind of plants or any kind of tissue need nitrogen to make protein, and oxygen, again, living things need to for respiration. So we breathe, and then plants use it for respiration. And argon, I actually couldn't find a good example of what we use that for. But first two, very important. We need them to exist. Sorry, this was just supposed to be a nice visual that shows you how small the proportion of other actually is. So we have 78% nitrogen, 20.9, or you can say 21% oxygen, and then we have it as a zero point 0.9 rather than a 1% for argon because we have the other gases that make up such a microscopic and yet such a critical part of our atmosphere. Okay, water vapor does vary a lot, which is why it's a good example of our variable gases. Okay, so variable gases is any kind of gas that changes in its percentage or its total contribution to the atmosphere. So water vapor can change because maybe we have rainfall, or maybe there's a lot of evaporation, or maybe it's in the middle of a desert and there's no water to evaporate. Carbon dioxide, we can have anything from maybe forests burning or no forests at all, or industries, factories, anything like that producing carbon dioxide, versus being out in a rural landscape where there's mostly vegetation and maybe less industry, maybe less carbon dioxide. Okay, so it does vary a lot. So those are the different types of chemicals that actually make up our atmosphere and how we look at the variable versus permanent gases. Okay, then like I said, we also have liquids and solids in the atmosphere. So liquids, usually your ideal example is water that has condensed. So when water vapor is in its gaseous state, but when it cools and it condenses, it turns into liquid, and that's how we would see it as clouds. If the clouds get too heavy, it would rain or fall from the sky, then we get precipitation. Solids can be ice or smoke or dust, or I like the salt crystals that obviously coming from the ocean. You have so many different types of solids in the atmosphere, and they are quite important because they do act as condensation nuclei for the water vapor. So what that basically means is that the water can't necessarily condense unless it can condense onto something. It needs to attach onto a surface. And that's what these little dust particles do. So they give a base for the water to condense onto, and then we get clouds. And now that we understand what actually makes up the gases of the atmosphere, we can take a look at the different layers of the atmosphere. We generally divide it into 4 layers, but we are going to see that there is a fifth one that can be counted, but probably not be counted. I'll explain in a minute. Okay, so the 4 main layers are the troposphere, stratosphere, mesosphere, and thermosphere. So I'm reading it from the ground up. Then after those 4 layers, we get a fifth layer called the exosphere. But I don't really know if we can include it in part of the atmosphere because its name literally means outside of the atmosphere. So it's technically a fifth layer. It's the layer that comes after the atmosphere. So it's more of like your outer space layer. Okay, so troposphere is what we see over here at the base that is in contact with the ground. This is where all of the real exciting things happen. This is where your weather happens, where we live in, where we see most of our cloud formation. Everything happens here in the troposphere. The stratosphere contains the ozone layer, very important for us. It also does a weird thing with the temperature. I'll explain that when I get to that one by itself. But it gets quite warm. No, not quite warm. It gets warmer as it increases in height. And that's the opposite to the troposphere or even the mesosphere. Mesosphere, it protects us from things like rocks or meteorite that come from outer space. And then the thermosphere absorbs a lot of the radiation that's emitted from the sun. That is why the thermosphere is so hot. So the troposphere is the layer that is in contact with the ground, and that is where all of our weather happens. So it does have different height depending on which part of the world we're on. So if we're at the equator, it actually reaches up to about 17 kilometers high, and around the poles, it's more about 8 kilometers high. The reason for this is related to the atmospheric circulation. So if we go back to our tricellular model, that is what this is. Then temperature tends to decrease with height or with altitude. So the higher up you go in the troposphere, the colder it gets. Typically at the ground, we can say an average of 15 degrees Celsius, but we know weather is its own thing. It can be a variety of different temperatures. And as you increase in altitude, it can get as cold as negative 60 degrees Celsius. So needless to say, just very cold. Then where the troposphere ends, or the top of the troposphere, this is what I was looking for. Okay, where the troposphere ends, so the top of the troposphere, is the tropopause. You can say it like almost pauses before the atmosphere continues. Okay, so it's the tropopause. It's around here by about like we average at about 15 kilometers up, more or less. And like I say, this is where all exciting things happen. This is where we have our weather. This is where we live. Um, we have a lot of aircraft flying in the tropopause, I mean the troposphere, but we'll notice that a lot of it also goes to the stratosphere, just because it's a lot more stable. So with everything happening in the tropopause, there's a lot of turbulence, and which means that the stratosphere is a lot more stable and a lot less turbulent. And that brings us to the next layer, that is the stratosphere. So the stratosphere starts at the tropopause, and it ends at about 50 kilometers above the ground. In this case, it actually gets warmer as it increases in altitude. So it starts at a very, very cold negative 60 degrees Celsius. That's where the tropopause was. And it warms up to a um, brisk 0 degrees Celsius. So still very cold, but it's getting warmer as it increases. Okay, and this contains the ozone layer. So the ozone layer absorbs a lot of the UV radiation, or the gases in the stratosphere absorb the UV radiation and it creates this ozone layer. And where it ends, it's called the stratopause. Now let's just go quickly to this diagram and I can finally explain to you how we actually figure out where the different layers end and begin. This red line over here is supposed to show us the temperature. So as altitude increases, the temperature decreases until it reaches about this point where it changes direction. And from there onwards, it gets warmer as altitude increases. That is where the tropopause is. So when it changes direction and temperature, we know that we've entered into the next layer. And it follows the same path through here, through the stratosphere, and then it gets warmer and warmer and warmer. And here you can see it changes direction. Instead of constantly getting warmer, it starts getting colder again. So that is how we know we've entered into the next layer, which is the mesosphere. Okay, so the mesosphere is the third layer of the atmosphere. This is the layer that protects us from a lot of incoming rock or dust or any type of debris coming through from space into the atmosphere. So when it enters into the mesosphere, it will experience a lot of friction and it will burn up before it actually reaches us here on the ground. So we typically find it at 50 to 80 kilometers above the ground, and it gets very cold. So it starts from the 0 degrees, that's where our stratopause was. It starts from 0 degrees and it keeps getting colder till around negative 80 degrees Celsius. Okay, and then that ends at the mesopause. So if we go back to our diagram, there's our mesosphere getting colder and colder and colder. I think this is actually the coldest that it gets. Let's just check. Yeah, it doesn't go below that. So the top of the mesosphere is as cold as the atmosphere can get. And then it starts to warm up again. It changes direction and it gets hotter. Then it completely swings into the opposite direction. And when we get to the thermosphere, it gets incredibly hot. So the thermosphere, actually named after the extreme heat, can reach anything from about 500 to 2000 degrees Celsius, also known as just very hot. Okay, so thermosphere is the hottest layer of the atmosphere. it also increases with increasing temperature, same as the stratosphere. So the two layers that get colder as it goes up is the the troposphere and the mesosphere. And the two layers that get warmer as it goes up is the stratosphere and the thermosphere. It's worth knowing those. Okay, so then it starts at about 80 kilometers above the ground, and that goes all the way to the exosphere. And the reason why this is so hot is because it absorbs so much of the radiation that comes from the sun. And then the last layer that I just want to brief over is the ionosphere. This isn't necessarily its own layer. This is a layer that spreads across multiple layers. So it overlaps with the meso, the thermo, and the exosphere, and it contains a lot of a lot of nitrogen and oxygen that reacts when it receives the radiation from the sun. So remember, I was saying the thermosphere absorbs a lot of that radiation. When it absorbs it, it actually causes the particles in that atmosphere, in that layer, to glow. And that's where we get these beautiful lights from. So yeah, here's the thermosphere. Here it continues to get warmer and warmer. I think it actually cuts off on this diagram. It doesn't get that, yeah, it doesn't show how hot it actually gets. But anything after that, you consider outer space. That's where you have your satellites or your spacecraft, and all of that works. What I wanted to try now, we'll see if it's actually a worthwhile activity. So this is a little website that I like to use for testing these sections of work, Quizizz. So Quizizz has a whole bunch of just literal quizzes that people have made and posted on here for education. So what I wanted to do is I wanted to see if I could find a quiz on this section of work, and then I'm going to try and complete it and see how much of my own work I've actually learned. So I don't think I'll be able to challenge you guys at the moment, but maybe in the future we can try that. For now, let's just do a practice run. Okay, let's see how we do. Which layer has the coldest average temperature? I'm going to say mesosphere. That feels like it's the right one. Yes, okay. I've also got these little power-up buttons over here that should give me extra points, but it's more fun when you're actually playing against someone. An important gas found between 10 kilometers to 50 kilometers from the Earth's surface. Yeah, that has to be ozone because that range is in the stratosphere, and the stratosphere has the ozone layer. Yay! We learned a thing. Earth's atmosphere can be layered based upon which factor? I'm going to say temperature. So remember what I was saying, how the temperature keeps changing direction and was zigzagging? That's how we figure out where the layers are. So I'm going to say temperature. So if I feel like these questions are too straightforward, I don't know. Let's do double jeopardy. There we go. Okay. In which atmosphere layer of the Earth do thunderstorms occur? So like I was saying, all our weather events happen in the troposphere. And I got double points. This is the second most abundant, plentiful gas in our atmosphere. Okay, the highest was nitrogen, that was 78%, and then the second was oxygen, that was 21. Are we remembering? At which height oxygen becomes negligible? Ooh, I have no idea. I don't know. Let's do a 50-50. Okay, mm, hmm. I'm thinking 120. I'm not quite sure what they mean by negligible. I'm gonna go 120. Oh, that was good luck. Whew. As you increase in altitude, pressure, okay, we haven't actually looked at pressure, but pressure decreases. That's because all of the weight of the atmosphere sits at the bottom. So as you move up, you have less atmosphere pushing down on you. So it decreases. Yay. Hmm. The layer of the atmosphere containing electrically charged particles. I'm going to say ionosphere, even though it does overlap with the troposphere and the mesosphere. That is the layer. Yes. Yay! Higher concentration of dust particle is found in. Oh, this is challenging. I'm going to say subtropical regions. Tropical is a lot of rain, so I don't see that being very dusty. Polar is icy. Equatorial, also a lot of rain. I'm gonna say subtropical because that's where we get our high pressure cells. So that's where we have the subtropical highs. I would expect it to be dry, deserty, probably dusty. Yes. Which statement best describes the ozone layer of Earth? Okay. It forms a magnetic field in the mesosphere of Earth. Okay, already no, it's found in the stratosphere. It increases the amount of nitrogen in. No, it has nothing to do with nitrogen. Remember, nitrogen is a permanent gas, it doesn't change. It helps reduce the amount of ultraviolet radiation. Yes. It prevents the formation of severe storms in the stratosphere. No, no. It has to do with filtering out UV. It's like sunglasses for the Earth. Dust particles are a mixture of which of the following matters? Sea salt, smoke, ash. I would say all of them. No? I think all of them make up dust. Carbon dioxide and water vapor exist up to which height in the atmosphere? Oh, I'm thinking 50. I don't think it would go beyond the stratosphere. I'm just thinking about the water vapor. I think 50. Oh, no! No! Can I get a redemption question? I want to try again. Okay. Damn it. Around 99% of the total mass of the atmosphere is confined at what height? Now I'm nervous. I don't know. Can I get like some kind of a boost? No? Okay. Uh, er. No, no, go away. I don't want to. Um, I'm gonna say 25. I'm sure some of it extends beyond the troposphere. So 25. I feel like this is gonna be wrong. 32. No. Okay, okay, fine. Atmosphere contains which of the following components? Dust particle, water vapor, gases, all of these. All of these. Definitely. Yay, okay, I can redeem myself a little bit. Hey Zebron, welcome. The height of the troposphere is 18 kilometers at the equator and only 8 kilometers at the poles because the Earth is flattened at the poles, air expands at the equator and contracts at the poles, Earth is bulged at the equator, and all of these. Hmm. I'm actually thinking all of them. I know that it does kind of bulge out at the equator, so then it naturally would be flatter at the poles, but also the whole air expanding at the equator because it's hot and contracting where it's cold. I'm gonna say all of them. No. Okay. Okay. This is bad. This is bad. Which of the following gases is essential for plants? Can I collect more than one? Okay, I'm gonna say carbon dioxide. I feel like, yeah. Plants also need oxygen. Redemption question. Which one? One, two, or three? Um, Two? I'm gonna go with two. Okay, now we know it's because the air expands to the equator and contracts to the poles. I've learned from my mistake. Here we go. Which of the following is the lowermost layer of the atmosphere? The troposphere. Yay, I can redeem myself. Which of the following gases is largely responsible for the greenhouse effect? Okay, we haven't done the greenhouse effect yet, but it would have to be a greenhouse gas. And that is the only example I can see. Yay! Generally, as altitude increases, temperature decreases. Usually, temperature decreases. Obviously, in the other layers, it can increase. Which of the following is the most abundant gas in the atmosphere? Okay, surely we know this one. 78% of the atmosphere. Nitrogen. Based on the choices provided, the outermost layer of the atmosphere is called the thermosphere. That is the one furthest from the Earth. It's also the one that absorbs all of the solar radiation. Which of the Earth's spheres is composed primarily of gases? Well, I can't even explain how the other ones are wrong. The biosphere, I think it contains all living things. The hydrosphere is everything to do with the water. Asthenosphere, I think that is actually the physical rocks, like the geology of it. I'm not sure. I'll have to double check that one, but obviously atmosphere. Which of the following gases acts like a blanket and contributes to the stability and instability of the atmosphere? Hmm. I'm actually a little bit torn on this one because both carbon dioxide and water vapor act like a greenhouse gas. But I think they're implying carbon dioxide. No, water vapor. Oh, okay. What is the relationship between atmospheric pressure and altitude above sea level? Atmospheric pressure is not affected by, no, that it absolutely is affected. Atmospheric pressure increases with increasing altitude? No. As you move up in the atmosphere, there's less weight pushing on you, so there's less pressure. So the pressure decreases with increasing altitude. Good. Atmospheric layer important for human being is, I kind of want to say all of them, but they're probably implying troposphere. You know, each of these play an important role. This contains the ozone layer. We need that. This protects us from, incoming space debris and all of that. We need that too. Ionosphere, it's pretty. We need pretty things in our life, but they're probably saying troposphere. Okay, get another redemption question. One, two, or three? I feel like I had decent luck with two last time. Should I do two again? Do two again. Okay, wait, this was 32 kilometers, if I remember correctly. 99% of the total mass of the atmosphere is 32 kilometers. Yes. Hmm. Oh, I get another redemption question. Yay! Oh, one or two. Hmm. I still feel like I've had best luck with two. Number two. Which of the following gases? Okay, this was water vapor. Acts like a blanket and contributes to the stability of water vapor. Yay! How did I do? What was my final points? 96% right. Okay, I'll take it. I didn't actually get 96% because I got a second chance on a lot of those questions, but I'll take it. I'm a little disappointed by that 4%. I'm a little disappointed by all of those wrong ones, but I did my best. Well, then I think we can wrap up there. I hope you enjoyed this. I hope you learned something new, maybe had a few questions answered. Thank you very much for joining, and have a lovely day further. Cheers. Bye.